Hello, Pirates. Today we are working on the MASH relationship lab. Uh, you're going to have safety goggles on. We have strong acids out. You're going to wash your hands with soap and water if anything happens. Let's get into the purpose of this lab. Today we are going to react sodium carbonate with hydrochloric acid to produce sodium chloride, water, and carbon dioxide. So if we were to simplify that, uh, we're going to make bubbly salt water. Okay. What we're going to do at the end of this, let's clear this off a little bit. We're going to compare the experimental with the theoretical. We're going to make salt in experiment and get that amount. That's the experimental amount. But beforehand, we're going to determine how much we should have made. That's the theoretical amount. Okay. The equivalent would be if I'm making chocolate chip cookies with my kids, I should end up with a dozen cookies. But after we make them and people eat the batter, I only end up with 11 cookies. Theoretically, I should have 12. Experimental, I had 11. That's what we're going to be doing today. Okay. So we have to do something first. If we look through the procedure, which you're going to see the procedure, now your teacher may want a beaker, they may want an evaporating dish. There's a bunch of different ways that it can look. So just ask your teacher for those. You're going to get your sodium carbonate, and then you're going to put 6 molar HCl. But it says calculate how many milliliters of that you should use. Okay. Well, here's what we have to do. Let's do a little calculation. Let's do it down here. I am starting with 1 gram of sodium carbonate. I know that because it says it right here in the lab. Get 1 gram. Get a scale, get a gram. Okay, get it pretty close. Now, you're going to put your exact amount, but let's say I exactly used 1 gram. Now, I'm going to go from, and if I pull out my trusty mole map, oh, shoot, should have cleaned it off first. Always using this thing, always have it ready, always using it. I'm starting off in grams of Na2CO3, CO3, and I am going to milliliters of a different substance, which is HCl. So I'm going to go to not this milliliters. I don't want to go to that one. I want to go over here to this milliliters, okay, because it's a different substance. That other substance I'm looking for is HCl. So I want to know how much I want to put in there. I don't want to put a whole lot because eventually we're going to have to evaporate it, and I don't want excess HCl. So this is the path that I'm going to use to get there, okay? I'm going to go through equation number 1, and then equation number 2, and then equation number 3, or equality, I should say, and then equality number 4. Okay, so that's what I'm going to be doing to getting here. I'm going to pop back to the lab, starting off 1 gram of sodium carbonate. I'm going to go to moles of sodium carbonate, and I'm going to cancel my grams using the molar mass of sodium carbonate. If this is a number that you're going to have to calculate, okay, if you need to do that, you can reference our earlier videos. And then I'm going to switch over to moles of HCl. Okay, so I'm in the moles to moles equation. Now I got to figure out where I'm getting those numbers from. This is probably a newer topic to you. I'm going to zoom all the way out. And what I first have to do is I have to look at this equation. I have to balance it. When I balance this equation, it's going to end up as 1, 2, 2, 1, 1. Okay, I come back here. I will switch my colors up a little bit. And I'm looking for moles of HCl is 2. So that 2 is going to go right there. And then I also want moles of Na2CO3. There's an understood 1 right there, so I put it there. Okay, so this becomes a 2 and a 1 from those coefficients. Now I'm in moles of HCl. I do not want moles of HCl. I want a volume of HCl. I'm going to go 1 liter to 6 moles because this is a 6 molar substance. So that's where I'm going to get that 6 from. Okay. And lastly, I'm going to get to milliliters by canceling 1 liter and 1,000 milliliters. This gives me 3.14 milliliters of HCl. So what that is saying is right here, let me switch up a little bit. I'm going to have 1 gram of this stuff and 3.14. Now, we're going to add a little bit extra just to make sure that this thing reacts. So we're going to add 4 milliliters. We know it should be 3.14. We're going to add just a little bit just to make sure it fully reacts. So 4 milliliters H2O. Okay. Now, that is the start of the lab. You're going to see the video on how the lab is done, and then we'll come back to this and talk about the analysis of the lab. All right, congratulations, you finished the lab. Here's our data that we're looking at, and I'll kind of highlight it as we go through. You started with 1 gram sodium carbonate. You took that and you mixed it with your HCl. Now we had, in that one, we had 4 milliliters of 6 molar HCl. You weighed your beaker. Maybe it was a evaporating dish, beaker, it doesn't matter. You have your mass of that, okay, empty. Then you did the lab and you have a mass of a beaker with salt, okay? One thing we can do, and it kind of comes down to question number 2 here, experimental yield, okay? Well, this number right here is my experimental yield. All I did was I took 6.3, that's my mass of my beaker and NaCl. I take out the mass of the beaker, and I'm left with 0.8. So that's what I got in the lab. That was my experimental value, okay? That's the easy one. This is the one that we need to figure out, okay? Theoretical. And that's coming from question number 1 here. We see we have the equation again. I go ahead, I balance that equation again. And so we say, okay, I got 0.8. How many should I have gotten? All right. So this wants weight of NaCl. So this is grams. I'm looking for grams of NaCl using the grams of Na2CO3. So go back to my mole map. Let's clear it back off. Again, this is where I'm using the grams of Na2CO3. So I'm starting with, I'm starting with 1 gram. Oh my gosh. 1 gram of Na2CO3. And I want to know how much NaCl I should make in grams. So I'm going to go to the other side because I'm looking at a new substance. This is grams of NaCl. This is what I'm looking for. Okay, so now I have my path. I'm going to go grams to moles to grams. Clear this out, come back up. I start with what I know. I know I used 1 gram of Na2CO3. I don't want grams of Na2CO3, so I cancel it. Molar mass of 106 per 1 mole of Na2CO3. And then I don't want moles of Na2CO3. I do want to be in moles of NaCl because I need to get to grams. And these are the numbers that I'm getting. NaCl's right here. Na2CO3 understood 1 right there. So I'm getting those two numbers from. And then I simply go to, it's 58.5 grams of NaCl per 1 mole. It's the molar mass. I run all that, and I should get 1.103 grams of NaCl. Okay, so that's what I should get when I do this. But then we have to go through and find out what we actually got. That step we already did, and then we can go down and talk about percent yields. We can talk about accuracy. When we get down here on the percent error, we like to use experimental minus theoretical, all divided by theoretical times 100. Okay, and that is what's going to get us our percent error. If I can mark this up for a moment, we got 0.8. Our theoretical was 1.1. We can run that equation. I'll let you do that math. All right, Pirates, thanks.